Welcome to Teaching in Blue with your hosts, Sam, Michael, Riley, and Skylar. We are here to help you fix your mistakes and talk to you about bond length. Let's take a look at the problem. We are asked to rank the following bonds, P, R, U, T, S, and Q, in terms of bond length. Before beginning to decide what is the shortest and what is the longest bond, there are certain things to consider. In determining bond lengths, there is a certain prioritized list of 4 criteria which help to predict which bonds are shortest and which bonds are longest. Number 1, bonds involving hydrogen, size of atomic radius. Any bond involving hydrogen will be the shortest bond in the molecule. However, when comparing hydrogen bonding amongst different atoms, the atom connected to the hydrogen that is the smallest causes the shortest hydrogen bond. Hydrogen bonded to fluorine will be a shorter bond than carbon bonded to hydrogen. Similarly, chlorine bonded to hydrogen will be a shorter bond than hydrogen bonded to sulfur. Number 2, bond order. For a given bond between 2 atoms, a triple bond is shorter than a double bond, and a double bond is shorter than a single bond. A carbon-to-carbon double bond is shorter than a carbon-to-carbon single bond.
Number 3, electronegativity. It follows a trend on the periodic table. Electronegativity increases across a row from left to right, and electronegativity decreases down a column. For example, oxygen is more electronegative than carbon. The more electronegative an atom is, the shorter the bond length will be. In terms of hybridization, sp is more electronegative than sp2, and sp2 is more electronegative than sp3. Any atom involved in a triple bond has a hybridization of sp and is more electronegative than an atom with an sp2 or sp3 bond. 4, partial bonds. Any bond that is involved in resonance structure can have partial bond character. If a certain molecule has resonance in a double bond, then that double bond will appear to be longer than expected due to the delocalization of the electrons in the double bond. However, if a double bond does not have any resonance, then that double bond can be expected to have a true double bond character. In a benzene ring, for example, each of the double bonds will appear to be longer than expected due to resonance, and the single bonds in the benzene ring will appear to be shorter than expected also due to resonance.
When going about solving this problem, breaking up the different types of bonds into categories based on the criteria given can help determine which are the shortest bonds and which are the longest bonds. Any bond involving hydrogen will be the shortest, and the smallest atomic radius involved in the hydrogen bonding will produce the shortest bond length. Bond P is the only bond that falls into this category because it is the only bond involving hydrogen. Any atom involved in a triple bond will thus be the next shortest bond, followed by a double and single bonds. Bond U and R both involve double bonds. In determining which of the double bonds is the shortest, we must thus look at the electronegativity of the atoms involved in the double bond. Bond U is shorter because it has more electronegative atom involved in the double bond, compared to bond R, which involves 2 carbon atoms. Oxygen is more electronegative than carbon. After that, since the rest of the bonds left are single bonds, we must now look at the electronegativity and hybridization of the remaining bonds. Bonds Q, T, and S are single bonds with atoms that have varying hybridizations and electronegativity. Bond Q is a sp2 oxygen attached to an sp2 carbon. Bond T is an sp2 oxygen attached to an sp3 carbon. Bond S is an sp3 carbon attached to an sp3 carbon. Based on the rules of electronegativity, bond Q is shorter than bond T, and bond T is shorter than bond S.
We have accumulated all the information. Now we must put it all together. Based on the specific and ordered ranking for bond length, bond P is the shortest bond length due to a bond involving hydrogen. Bond R and bond U are double bonds. Both atoms involved in the bonds are sp2 hybridization, but U is shorter than R because oxygen is more electronegative than carbon. Bond Q is a single bond between an oxygen atom and a carbon atom, both with sp2 hybridization. Bond T is the second longest bond because it is a single bond between a carbon and an electronegative oxygen, with the oxygen having an sp2 hybridization and the carbon having an sp3 hybridization. Finally, bond S is the longest bond because it is a single bond between 2 carbon atoms with sp3 hybridization. Thanks for listening.